we are working on section 8.3, which we are going to talk about zero and negative exponents today. In your homework, there was that one question that said, really, you had to know something about negative exponents in order to do that one. I leave it in there to see what people will do with it. It's a precursor to this, but the author probably shouldn't have had it in there because you need this next piece of information really to know what to do with it. Please, right now, accept on faith, and it will become more clear to you as we go through our class, accept on faith that a to the 0 power is equal to 1. I will prove it to you, but right now, accept it on faith. Also, note that when you have a number raised to the negative power, we are going to move that base with its exponent to the other side of the fraction bar, and we get to change it to a positive exponent. Okay. Remember when I had that problem with Jake and we had y to the negative 13th? And then our answer ended up as y to the positive 13th down in the denominator. We get to move a base with a negative exponent to the other side of the fraction bar line, and it becomes a positive exponent. The same is true if you have a negative exponent down the denominator. You can move it to the numerator, and it becomes a positive exponent. We'll do a bunch of problems like that today. So that's what the second one then is saying here, that if it's negative down in the denominator, I can move it up to the top. Okay, once I move it to the other side of the fraction bar line, its exponent has to change signs. Okay? And on each one of these, a cannot equal 0, because when you look at this, I have a denominator that has a in it, and I can't divide by 0. And as I said, take this first one on faith. I'll prove it to you in a little while. Any questions there? Jake?
So I don't know, technically if you like to work with negatives, I guess if more people do, but if you have like a positive and you want to make it a negative, just flip it to the other side.
Exactly. When we do our answers for section 8.3, all answers will have positive exponents when you get done. For section 8.3. I'll change that direction just a smidge when we talk about 8.4. Okay, so for today, all problems will have positive exponents when you get done with them. You should not leave any exponents to be negative. Be positive, don't be negative. Okay? Cassie?
So for the third one, can you just leave it as a to the, as it was, because it's opposite?
What they're trying to show you here, Cassie, on this third one is if it is in the denominator, you move it up to the numerator, or if for some reason I have to move it to the denominator to gather things together, once I flip it, it has to turn the opposite of what it was.
But you can just leave it if it was like that.
Technically, this is the answer that we always want. We always want a positive. But sometimes we have to move it to the other side of the fraction bar line in order to work with it. So it has to become the opposite of what it was. All right? So I'm just going to leave it at that right now. Okay, Adam.
So if you move it, then do you want us to move it so we can simplify our exponents?
That's what's going to happen along the way. Sometimes we're going to have to move it in order to make our simplification easier. Okay? All right. Anybody else? All right, let's start out here with 2/3 raised to the 0 power. Talk to your partner real quick, decide what that answer is. And you all say? 1, that's right. Any number raised to the 0 power is 1, as long as what is not 0? The denominator. As long as this thing down here isn't 0, we can do that. I will prove it to you after a bit. Right now, take it on faith, okay? Kind of like taking God on faith. It will. You're going to go, oh, now I see. Take it on faith, because I got to teach you a couple other things before I can teach you that. Okay? negative 8 raised to the negative second power. We are going to rewrite this problem so that it has positive exponents, and then we're going to simplify it the rest of the way. The first thing we're going to do is we're going to draw a fraction bar line. And we're going to move that negative 8, that's the base here, to the denominator of our fraction. And we keep that a negative 8. That doesn't change just because we moved it. But what does change? The exponent. The negative 2 becomes positive 2. So I'm going to put a positive 2 here. And what am I left with up in the numerator? Anybody know? Go ahead. It is a 1. That's right, Luke. Okay. I will have a 1. Don't put a 0 up there because you guys know what 0 times something is. 0. So that would be a bad thing. There's a 1 up there. Michael?
What if the exponent was a negative 3, then what would come out to be a negative number?
Okay. The answer when we apply that negative, yes, will still be negative. This answer down here will still be negative. But this number doesn't matter whether it's an even or an odd. When I move it across the fraction bar line, it becomes the opposite of what it was. Okay? So hang on, let me finish this and then you can ask some more questions, okay? Negative 8 raised to the second power class is?
64.
It is not negative 64.
64.
It's positive 64 because it's a negative 8 times a negative 8. So I get a positive 1 over 64 for my final answer. When I am writing it, and I need to write this so that you can see it easier, kind of scribbled on top of it. Notice that what we have up here, the negative 8 raised to the negative second power, I move it to the opposite side of the fraction bar line. The base stays the same number it was. That never changes when you move it. Sometimes students do that, so that's why I'm cautioning you. It's the exponent that changes only. Then we can figure out, hey, what is negative 8 to the second power? It's 64, and we can finish simplifying. Evan?
Could you just like make the answer? Because you know what 8 times 8 is.
I do know what 8 times 8
But
is.
you could do that mentally, but do you have to show like putting it in a fraction again? Or
You need to show changing this into a
Yeah.
fraction. Yes. And then you're going to have to finish writing it by simplifying it, because this is not done yet. Okay? Adam?
So you'll never take a negative number without an exponent and put it like either above or below the fraction bar to change it?
No. Are you talking about the negative 8?
Yeah, like if it's
Yes.
just a negative 8.
Negative 8, when you move it across the fraction bar line, does not change because you moved it. It's just the exponent that changes. Okay. Luke?
So when we, after we take negative 8 to the second and we get 1 over 64, that's like our answer right
That
there.
is your simplified answer. Let's try another one. 1 over 2 to the negative third power. Okay, this is similar, Cassie, to that last problem, that last property that was up on there. Right now I've got a negative down in the denominator as my exponent. Okay, and I want to write this with positive exponents to begin with. Okay, any ideas on what we're going to write with positive exponents to begin with here? Any ideas? Andrew? 2 to the third, and that's in the numerator, right? Okay, and yes, the third negative 3 here became a positive 3 here. If you have to, think of this over 1, but I generally don't. It's in the numerator, right? 2 to the third class is?
8.
So there's our final answer, 8. 1 over 2 to the negative third down in the denominator. We have to move that across the fraction bar and change the exponent to be positive. Okay, the exponent's always going to change its sign when it moves across the fraction bar line. The base does not change its sign. That's affected only by how many times I'm multiplying with the exponent. Questions? Negative 1 to the 0 power. How many people think it's 1? How many people think it's 0? How many people think it's a negative 1?
Yeah. Put down your hands.
It's a positive 1. It's always, always, and forevermore. Amen. Hallelujah. That's how it's going to be. Positive 1. That's right. I was a little bit, for sure on that, aren't I, Graham?
She was a preacher.
Preach from the pulpit. I'd let Father Kautsky say, any number raised to the 0 power when its denominator is not equal to 0 is equal to 1. He could say that from the pulpit. The Pope could say that. Okay? Maybe he can say it from his chair and it'll be doctrine, right? It is already doctrine in the mathematical community. Let's do this one. 6 to the negative second. How are we going to write this with positive exponents? I'm going to pause this. We're going to get some people. So as we see that we should have moved the 6 to the denominator and kept the 6 positive, its sign doesn't change. The sign on the exponent is the only thing that changes, and then we have 1 over 36 for our final answer. Okay, questions there? I'm glad I had you guys go up on that one. Yeah. Okay, next one here. X to the 0 power is? 1. 1. Any variable raised to the 0 power is going to be a 1. Okay? Pope decreed that, right? NCTM decreed that, I'm sure. Maybe Pythagoras decreed that. All righty. 2/3. You don't know who Pythagoras was? The mathematician from back in before Christ. All right.
Did he make the Pythagorean theorem?
Yes, he did. Actually, he and his followers did. The Pythagoreans.
He had followers.
Ladies, gentlemen, you know what? You're going to get an extra little homework assignment today.
Oh.
And you're going to have to find out who Pythagoras was.
Oh, I didn't bring I already know.
This is how you spell his name.
Oh, my God.
Wait, is this like a serious thing?
This is a serious thing. If you don't know who Pythagoras was, you need to find out just a little bit about him.
Is that an R or an S?
He created the Pythagorean
Ladies and gentlemen.
He created the Pythagorean theorem.
Yeah, true. He and his followers created the Pythagorean theorem. So you need to find out. No, you need to find out more than that.
He was popular.
Ladies, gentlemen, let's see here. I am going to do this because I have not done this with you guys yet. I am going to put out on Edline an interactive Edline assignment. And what it's going to be is
Extra credit.
give me just a short little paragraph on Pythagoras. And you will submit it via Edline. Now, how many in here have never done an interactive Edline assignment before? Okay. That's fine. Put down your hands. We will talk about at the end of class. Remind me to say this is where you need to go, and you will see it later today. It's not out there right now because I have to create it first. And you get to type it right into Edline and you submit your answer.
Given this study class?
I think I will.
Are you doing that?
I think I will.
Yeah, at least it's not just us. I guess that's good.
Yes. There you go.
Who even started this?
You.
Yeah, but I can't remember how it started though.
And
You just gave
if I remember, I'll bring something on Monday.
Yeah, we can listen.
Because you were like,
Yeah, we could listen to it.
Let's rewind.
All right. Anyone listening to this will be thoroughly amazed. Let's have 2/3 to the negative second power. This is something that we need to talk about a little bit here because this is a fraction raised to the negative second power. All right. Hang on. Do you remember fractions? And there's a word that starts with R that we use a lot in fractions. Reciprocal. Okay. Hang on because I'm going to show you something long and then I'm going to do it the easy way. Okay. Technically, we should move what is in the base to the other side of the fraction bar, right? And write its exponent with a positive exponent, right? Technically, that's what we're supposed to do. And thus, that gives me 2 to the second power class is 4. 3 to the second power is 9. How do we divide fractions? Multiply by the reciprocal. So I'm really taking 1 times 9/4, right? So my answer is going to be 9/4. Okay, notice I moved it to the opposite side of the fraction bar. I simplified it. I divided. I got 9/4. Life is good. Let's make life better. Okay. So I have 2 to the third power, 2/3 raised to the negative second power. Easy way to do this is take the reciprocal and make the exponent positive. Isn't that nice? How easy! Just take the reciprocal of the fraction and make the exponent positive. Doesn't that make your life so much better? Yeah! Jake!
Could you technically do like a fraction of 2 times -2/3 times -2 and then flip them so it's...
Oh, Jake. Oh. So you want to say 2 to the negative second power over 3 to the negative second power first? Yes, you can! Move this to the other side of the fraction bar line. 2 to the now positive second power. 3 to the now positive second power. Ain't that cool? Excuse me, isn't that cool?
It's gonna be a fun one to listen to.
I'm gonna listen to this when I get home. Hey, myself.
All right. Anybody else?
Said hi to
We're
myself.
going on. 0 to the negative seventh power. Ooh, you think you know this one. All right, Tyler, what do you think?
Well, it can equal 1 because you said it can't equal 0. So
Oh, it can't equal 1 because I said what can't be 0?
the base.
The base. If I move this, first of all, there's going to be a 1 up here, right? And 0 goes to the denominator with the 7 positive. And Tyler said I can't divide by 0. So what's my answer? Undefined. That's correct. So if I take 0 and raise it to a negative power, and I try to, rewrite that as with a positive power, all of a sudden I have 0 in the denominator. No, no, never, never. You can't do that. Okay? You're going to remember this. Miss Cassie.
What is 0 raised to a positive power?
Oh, 0 raised to a positive power? Let's check it out. 0 times 0 times 0 times 0 times 0 times 0. What do you think?
0.
0! Praise the Lord, it's 0. Is it sinking in a little bit? No, it's not. As long as we're not sinking like in a boat, okay?
It's getting scared.
Oh, I'm sorry, I'm scaring you. You'll remember this. Remember what we've learned so far. Okay, this is all my handwriting because I started retyping these and this is where I stopped. Sorry. All right, so we know that a to the m times a to the n is really a to the m plus n. A to the m raised to the n is really a to the m times n. AB raised to the m is really a to the m to the m. We did that with the multiplication step. The other day we learned the division, m minus n, and also taking that inside the parentheses, as Jake wanted me to do with that -2. Right? And all of these, the denominators cannot be 0. This is everything we've learned so far. You all remember that?
Yeah, just kidding. It was a joke.
When we started chapter 8, did you know all of that?
No.
See how much you've learned in 1 week? Holy cows, you can go home and say, Mom, look at what I've learned.
And we can learn about
And you're going to learn about Pythagoras. All right?
and his followers.
Yeah, and his followers.
Okay, so, all
All
right.
right. Me that started that. She's the one that said it.
So now I have a problem where we're going to put this stuff all together. negative 2 to the 5th power, and negative 2 raised to the negative 5th power. Oh yes, I gotta make it work a little bit. It can't be all fun and games, right? So let's rewrite this problem so that there are no negative exponents in it. Okay, I'm gonna get my sticks out a second. Let's take a look at this. We have in green here, negative 2 to the 5th power. This is this. Okay, that's in the numerator. Then this was put down here so that it had a positive exponent, but notice the base. What happened to the base? Stayed the same, exactly. If you take a number and divide it by itself, what do you get? Kayla?
1.
You get 1. A number divided by itself is 1. Let's think back to what we've learned so far. Remember this little thing right here? Let's see, right here. We're subtracting. All righty. I have the same base, correct?
Mm-hmm.
What's 5 minus 5? 0. So I have negative 2 to the 0 power. Shouldn't that be equal to?
1.
1. Oh, stay up here. When I multiply two items that have the same base, what do I do to their exponents? You add them. So I have negative 2 raised to the 5 minus 5, right? 5 plus a negative 5. What's 5 minus 5?
0.
So this is negative 2 raised to the 0 power, which is equal to?
1.
Hey, look at here. Here's my proof to you that it equals 1. It's a number divided by itself.
I'm confused now.
Brad.
I was following you very well.
Awesome. Whoa. All right. Whoa. Whoa. Let's come back to this. Brad, do you agree that we can rewrite this first part up here so that it is negative 2 to the 5th over negative 2 to the 5th?
Yeah.
And do you agree that a number divided by itself is 1?
Yeah.
Cool. Now, you also know from what we've learned so far that if I have the bases are being the same, I can subtract their exponents, right?
Mm-hmm.
And 5 minus 5 is 0. So that means negative 2 to the 0 power also has to be equal to 1. And up here, you remember this is the same as this, right? The top section, same as this middle. So when I multiply 2 together, I get 5 times 5 minus 5. I have to add their exponents, which gives me negative 2 to the 0 power, right? Well, if this top section is equal to this middle section, doesn't that mean that that has to equal 1 also?
Yeah.
So any number raised to the 0 power, we therefore conclude, must always be equal to 1. It's because if I would add the exponents together, I'm going to get 0. If I write them with positive exponents, Brad, I get to divide a number by itself. Better? Maybe not completely. You might be a little wiggly in there yet, but you're getting closer to agreeing. Okay. Anybody else? 3 to the 3rd, I'll raise to the negative 2nd. Okay, we got to bring all of it in here. I want you to write this. When we take a power to a power, what are we supposed to do? Please use that in your logic and your steps here, okay? I'm going to get 5 more people up. Wait, come in. Ladies, gentlemen, back to the front, please. We have 3 to the negative 6th power because when you multiply these two together, you get negative 6. Now, we have to write it using positive exponents, which is where Austin got 1 over 3 to the 6th power. He moved the 3 with its exponent to the other side of the fraction bar line. The exponent became positive. Nothing happened to the 3. Now, if I made you come up with 3 to the 6th power, could you do it?
729.
729. Cassie, question?
Well, I was going to say is like 1 over 27 squared. Can you do that?
No, you are not going to leave it as 1 over 27 squared. because you are already starting to simplify it. Okay, thank you very much. You're not done. They're going to ask you to finish writing these. Okay, I wanted you to write it with positive exponents. I knew that most of you would get here, because what I would hope that you would have done is taken 3 times -2. What you did, Cassie, was 3 cubed, which is 27, which is not wrong, okay? It's not the path I was thinking about going down. But you did write it correctly with positive exponents, 27 to the 2nd power. Now we got to finish it out. And you'd have to take 27 times 27. I can actually do 3 of the 6 in my head. Okay, 3 times 3 is 9, 3 times 3 is 9, 3 times 3 is 9. I know 9 times 9 is 81, and 81 times 9 is 729. So I would have to do paper and pencil to get 27 squared, because I can't do all that calculation in my head.
If I wrote that on a test,
It would not be done, so yes, you would get points off. Okay, if I say write using exponents, this is what I'm actually going for here. Multiply those together, keep the base the same, okay? And then write your answer using positive exponents, 1/3 of the 6, all right? Then I'm going to ask you to go the rest of the way and simplify it and make it 1/729.
so if it says simplify, then
Simplify is all the way. Simplify right using exponents is right here. Okay, the right using exponents is an important piece there. Katie?
so when you say right, you always want to be positive.
You always want your answer to be positive. Yes, Katie. Always, always, and forevermore. Amen. Hallelujah. In this section, that's how it's going to be. Okay? That's what I'm thinking when I do my 3s.
If you said just to simplify the exponents,
Technically, I'm going to say, yeah, you probably could, but I'm not going to let you stop there, Cassie.
Yeah.
I'm going to make you go to 1/729, okay? All right. We got to keep on moving here, ladies and gentlemen. 1/8 to the -2nd power. Would you please write this? Okay, ladies and gentlemen, as these are going across here, this is honestly the easiest way to work with some of these. We've got that 8 squared equals the 64. Life is good on that question. Any problems there? Okay, let's go on here then. I have 7 to the 3rd over 7 to the 5th. You need to simplify this, please, and then simplify your answer. I'll get last 4 people up to the board. Front, please. Up here, Andrew took 3 minus the 5 and got a -2. Remember earlier when I commented you subtract numerator minus the denominator exponent and always write it in the numerator?
Yeah.
That's where we wrote 7 to the -2. Then, next Andrew wrote it with positive exponents, so it was 1/7 squared. Exactly what we've been doing. 7 squared is 49, so it's 1/49. Now, the way I was taught in high school, I never learned the subtraction rule, I didn't. There were 3 7s up here, they cancel with 3 of them down there, so I would have gone straight to, it's 1/7 squared, thus 1/49. Okay, maybe some of you are looking at it and thinking that too, going, those 3 on top cancel with 3 on the bottom. I got 2 left on the bottom. I'm going to write it as 1/7 squared. Cool, go ahead and do so. Okay, Andrew, that was your question? Okay. What you did up here is exactly what I was looking for to describe. This is the process that we are doing, but there is a shortcut. Okay, and you may do that shortcut, that's okay. Questions? All right, we're going on here then. We're going to use the properties. We're going to write our answer with only positive exponents. So I want you to take a moment and do this problem with your partner. Okay. And looking at the board. You both have done correct work. It's okay, just let it look there. What Katie did with her y to the -15 is she drew a fraction bar line and put it below the fraction bar line. That's what I want you to do. Luke did the same thing over here, but he made it a separate fraction. Don't have to.
Oh, you know.
Nope, you can put it right underneath. Cool, that'll make life a little bit easier for you, okay? And then, yes, you do have to simplify those coefficients. Adam?
Why do you have to simplify it? Because it says use it, write the answer with positive exponents.
With only positive exponents. This is one is negative right here. So I've got to make it
Why
positive.
can't you simplify the 2 to the 3rd? Just
Because I want you to simplify and write your answer so that there are only positive exponents. I don't want you to write. Let me take a step back here. Any exponents that are negative must be written positively, and you have to simplify any constants raised to a power. Does that make better sense, Adam?
Yeah.
Thank you. Okay.
Is it okay if you would have done like 8x to the 3rd times 1 over 5 to the 15?
That's what
That's fine.
Spencer has over here, hon. And I said, that's okay, it's just extra work. You don't have to do as a separate fraction. Okay? Work smarter, not harder. Okay? All right. It's just extra work. Does that make sense? It's not wrong. What did I say? Oh my gosh.
This has been a rough day.
It has been a rough day. Okay, let's go on. Spencer, I'm sorry. Luke, I'm sorry. All right, here we go. This one's a good one. We're going to go step by step through this one, then we can check to see if Andrew's answer is right. First of all, ladies, gentlemen, you could distribute that -2 in and rewrite it with that in. I wouldn't do that. Or let's go ahead and start rewriting this with positive exponents right away. So that I'm going to have my y to the 5th up here. This 2x to the -2nd comes down to the denominator, right? And each one gets a +2, doesn't it? So let's go +2, +2. This -4 sitting here stays down there. That's -4 times that 2 squared times that x squared that we have. This x squared is still down there. And this y squared is still down there. Can you see that happening? Now let's start combining. I got an x squared and an x squared. What does that become?
X to the 4th.
X to the 4th. I got y to the 5th divided by y to the 2nd. What
Y
is
to the
that?
3rd.
Y to the 3rd.
And where's it written?
Numerator.
In the numerator. Y to the 3rd up here. 5 minus 2. Okay? Then I got a 2 squared, which is equal to
4.
4 times the -4 down there. So what's -4 times +4?
-16.
All right, so I'm going to put the 16 in the bottom.
-16.
And I'm going to just pull that negative sign out in front of the fraction. Could I have it in front of the 16? Yes, I can. But the whole fraction is really negative.
So it wouldn't be wrong.
Nope. It's not wrong to have this.
Is it alright if you have 1 times y to the 3rd? Does it matter if you have
Don't have one up there. It's redundant.
Is it wrong?
It's redundant.
It's redundant.
What's up, B?
Saying the same thing twice
Oh, alright.
in a different way.
Alright. That's what I think that I
All right. So I'm going to go back one screen. Let's see. Once was it was y to the 3rd over -16 x to the 4th. Not quite. Not quite. And can you see what should happen there? Have you corrected your notes, please?
Yeah.
Okay.
I just messed up on the.
Just a little bit down here. Yeah. 4 times 4 is 16, not 4 plus 4.
That's what I was thinking.
Okay. Let's move on. Ooh, this one looks good.
Susan, are all these last
You know what? You know what? We're jumping.
Oh, yeah!
The order of magnitude, guys and gals, please. The order of magnitude of the mass of a proton is 10 to the 4th times greater than the order of magnitude of the mass of an electron, which happens to be 10 to the -27 grams. That's a -27 here. Find the order of magnitude of the mass of a proton. The order of magnitude of the mass of a proton is 10 to the 4th times greater than the order of magnitude of the mass of an electron, which is 10 to the -27. Find the mass of a proton. Talk to your partner a second. The order of magnitude of a proton is, do we know how much a proton is? Is 10 to the 4th times greater. So 10 to the 4th times the order of the mass of an electron, which is 10 to the negative 27. Find the order of the magnitude of the mass of the proton. That's what we're trying to find. 10 to the 4th times 10 to the negative 27th gives us 10 to the negative 23rd. I can't have that as a negative. 1 over 10 to the 23rd. What number is that?
A really big one.
1 over
23 zeros.
and 23 zeros. Yes, 23 zeros. Holy cow.
You don't divide.
Oh, I get it right.
You don't have to divide. You just write 1 over 10 to the 23rd.